Okay guys, today what we're going to be going over is a new thing called the Polygon sum conjecture. Now let me go with some back knowledge with triangles since that's the last thing we really talked about. And then we can go into what the triangle sum, I mean not triangle, the Polygon sum um, conjecture is. So first, we know triangles. First thing we know about triangles is that they all add up to all the angles inside of the triangle add up to 180 degrees. So we know that the x, y, and z, if we take x plus y plus z, just giving each angle its own variable, if we take all that, that should equal up to 180 degrees. The next thing, though, is that if you have a triangle, okay, let's call this little angle right here x. If you extend out this angle right here, let's call this x1, just to call it a different. So x and x1, okay, so this is just saying two different variables, okay, even though they both have x, one's called x1. If you take both x and you add up x1, you should get 180 degrees. So the thing about triangles is that if you take an interior angle, which this is on the inside, an exterior angle on the outside, we did that by extending a line. Okay, so we extended the baseline right here out. This is an exterior angle. If you take this and this, it should add up to 180 degrees. Even if I moved the exterior angle, the same idea still had. If you had this angle right here, this angle right here, these two should add up to 180 degrees. That just tells you that if you have a polygon and you have an exterior angle, when you add them together, you should get 180 degrees. Now, this is just a triangle. So triangles all add up to 180 degrees. The exterior with an interior angle, an exterior and interior angle, should always add up to 180 degrees. Now let's get into what the the conjecture is. So, what we look at is we know triangles are 180 degrees. Now, we gotta ask ourselves, how much would a square be? This is actually how you find how much a square would be. You see that you have a square, okay, and we gotta figure out how many triangles can we create without crossing lines. Let me explain what that means. So, if I take from this point to this point, I make a little line here. Okay, see that it creates two triangles, one here and one here. Now you're thinking to yourself, well, I can create more triangles by doing something like this. That creates more triangles, right? Well, it does, but it's getting past the point what we're trying to make. Is you're trying to make triangles by just connecting points up from the edge. Okay, so like you have 4 points on a rectangle, or any type of quadrilateral, meaning four-sided figure. If I created this line right here, it would have to either touch or cross the second line here in order to have make more triangles. This doesn't work. Okay, we want to make triangles, all right, in which it's created by taking one point, connecting it to another, without crossing any of the lines we previously created. So this wouldn't work because this line crosses the line we just created. So this wouldn't work. So when we have our little square, we can only make one line. Okay, that only creates one line in which we do not have another line crossing this line to create triangles. So we only can make two triangles out of this rectangle. And as we know, every triangle from earlier, every triangle adds up to 180 degrees. So this is the way you can figure out how much the interior angle should add up to. So we have two triangles. So you have 2 times 180, which gives you 360 degrees. Then let's look at a pentagon. Pentagon meaning 5-sided figure. So we've got a pentagon there. We're going to do the same idea. Okay, so you can only touch edge to edge. So we're going to connect this edge and this edge. It doesn't matter which edge you do, but you can only touch one edge to another. Okay, so that creates one triangle. Well, I can't take this and connect it to either of these 2 points because that crosses the line we just created. So this little edge right here, this vertex, is off limits. Okay, so now let's go to another one. Okay, so this one, okay, so I have two options. I can either connect it to here. Actually, I have one option. I can connect it to here. Because if I connect it to this one up here, this and this just makes the line that we have already created. So we're just going to do this. Connect from there to there. Okay, so this can't connect to this point, this can't connect to this point, this can't connect to this point. Alright, let's get this point. This can't go there, this can't go there, because if I do, it will cross lines I've already created, so on and so forth. So, we have a 5-sided figure. So we have made it 3 triangles. So once again, to figure out the degrees, we take 3 times 180. We get 540. And as you can guess, as we go up, as we add more sides, this number only goes up by 1. Okay, so if I had a 6-sided figure, I'd only make 4 triangles. Let me show you that. So let's say we had a 6-sided figure. 1, 2, 3, 4, 5, 6. Okay, we have a 6-sided figure. I'm just going to take this and make 1 triangle there. Okay, so that keeps this point from being able to be used. Let's take this point right here. I don't know, let's connect it to the same thing we just did. Okay, and then last, we can only make 1 more. We can't make any more triangles without crossing any of the lines that we've already created. So we've got 1, 2, 3, 4 triangles. And we take 4 times 180 and get 720. Now, there's a conjecture we can make about this. Well, when you have one triangle, it's 180. Okay, so that's like 1 times 180. Then, we look at a 4-sided figure is 2 times 180. A 5-sided figure is 3. 6-sided figure is 4. Okay? Every time, we're technically doing this. With a 3-sided figure, okay, triangle's 3-sided figure, we take 3 minus 1. Okay, so because we take that 3. 3 minus 2. And we multiply it by 180. Okay, 3 sides minus 2. Now you're asking yourself, well, why did I pick 3? Or no, why did I pick 2? 3 measures the amount of sides we have. We have 3 sides. Why did we pick 2? Well, let's think about this. How many 180s do we have right here? We got 180, right? Since we only have one 180, we gotta think to ourselves, 3 minus what equals 1? Well, 3 minus 2 equals 180. Okay, this is just part of the conjecture. Okay, so let's look at the next one. 2 times 180. Well, let's look at it like that. 2 times 180 equals 360. Well, how many sides are there? There are 4. Let's subtract our 2 again, because we're trying to get to 2, so the only way you can get to 2 is take 4 minus 2, and then you multiply it by 180. Well, 5-sided figure. Well, once again, 5-sided figure has, we're going to have 3 triangles, meaning 380. So we subtract 2 again and multiply by 180. This is the conjecture that we're making. Our actual formula for this is this. N minus 2 times 180. Now, N represents the amount of sides we have. So if it's a triangle, it's a 3-sided figure. If it's a quadrilateral, it's a 4-sided figure. If it's pentagon, 5, hexagon, 6, so on and so forth. If you, however many sides the figure has, you take that and replace it with N. So let's say we wanted a 20-sided figure. So if we take the 20-sided figure, meaning it has 20 sides, we replace it with N. So 20 minus 2 times 180. Well, let me figure this out real fast. If we take 20 minus 2, we get 18. And if we take that 18 and we multiply by 180, we should get, so this will be 18, and multiply it by 180. That gives us 3,240. That means that all the interior angles, when added up in a 20-sided figure, equals 180. Let me re-explain that in a little bit easier way to see. So, remember that rectangle we had earlier? Okay, so we know that since there's 4 sides, we take 4 minus 2, which is 2, multiplied by 180 would mean that a 4-sided figure has 360 degrees on the inside. So this is, what if I told you this? I told you this was 60, I told you this was 60, and I told you this was 70. Okay? I said those 3 angles are that. Try to find a 4th angle. Well, you're looking at me like, I don't know what I'm doing. Well, you're going to think about this. How many sides does it have? It has 4 sides. Okay. We do a little conjecture thing, and we figure out it has 360 degrees. Well, if we know 3 of them, we can just subtract those away. Subtract away the first angle, subtract away the second angle, subtract away the third angle. If we did that, it would be 190 we're subtracting away, which would mean that we would be left with 170. Okay. This is the concept you got to think about. Okay, so if we had a 5-sided figure, if we had a 5-sided figure, let's say this was 65, 35, 85, 95. Okay, so we had all of those things. Well, this is a 5-sided figure, and you're asked to find the last side that's remaining. Well, it's a 5-sided figure. So we know a 5-sided figure is, let's first figure out our conjecture. N meaning 5 minus 2 times 180. So let's figure out how many degrees are in here. 5 minus 2, which is 3, times 180. This gives you 540. Okay, so that's how many degrees we have to work with. That's how many degrees these little interior angles should add up to. So if we're trying to find a missing one, we just got to take what our total amount is and subtract what we already have. So we'd subtract 35, we'd subtract 65, we'd subtract 95, and we'd subtract 85. So, 100, 280. So you take 540, And when we subtracted everything, what we'd end up with is subtracting 280 and we would get 260. Our final angle would be 260 degrees. And so, as the things get bigger, your number of degrees on the inside is going to get bigger. Okay. But going back now to what we were explaining earlier about exterior angles. Okay, so exterior angles should always, with the angle itself, should always add up to 180 degrees. Now, sorry, let me go back to this. So, if I said if I added up all the exterior angles, okay, so let's say we had another exterior angle there, and we had another exterior angle here, okay. So, if you had y1 and y, z and z1, okay, all the exterior angles next to z are going to be z1. So even if I made another exterior angle over here, it'd still be the same amount. Y, y1, so on and so forth. So all of these, if I take all the exterior angles, x1 plus y1 plus z1, those should all add up to be 360 degrees. All exterior angles, no matter how big the figure is, all exterior angles add up to 360 degrees. Okay, so when you get to something like this, even though the entire interior angles add up to 540, all the exterior angles are still going to add up to 360. Even though we have right here like a 20-sided figure has 3,240 degrees on the inside, it's still the exterior angles will add up to 360 degrees. With that concept, you got to be thinking, okay, so you can actually figure out how many sides a figure has just by knowing the exterior angles. Okay. Now, that's the conjecture formula. Now I'm going to explain the next thing. It's called a regular polygon. Okay. A regular polygon means this. So with triangles, we talked about equilateral triangles. Equilateral triangles being that all three angles are the same. The reason why all three angles are the same, this should be a 6. It looks like 100, but it's a 6. All three angles are 60. Okay. This is because all three sides are of the same length. All three sides are of the same length, that means all the angles are of the same length. So if I would mark this, it would look like this. This is what a regular polygon would look like. It would be an equilateral triangle. With a four-sided figure, it would be a square. And as we know, squares have 4 equal sides. Except for the difference between this and this, is that all the degrees are going to be 90. Or right triangles. Okay, so all those are 90 degrees. As you increase the size of a regular polygon, it increases the size of the angle. But all the angles must be the same on regular polygons because all the sides are equal. So with a 3-sided figure, it's a triangle. With a 4-sided figure, it's a square. Five-sided figure, it's just called a regular pentagon. It just means this. Okay, so you have five-sided figure. I know it's not going to be perfect looking. Let's pretend that all the sides would be equal. This would be 120 degrees each. I believe, no, 105. Actually, oh, okay, I'm sorry. 108 degrees each. That's what it would be, sorry. So all these would be 108 degrees because this is called a regular pentagon. As you get bigger, when it says regular, it just means that all the sides are equal. Or all the sides are the same, so all the angles should be equal. And how you figure this out is, since like a triangle, it has three sides, and that's up to 180, so you take 180 divided by 3, that gives you 60 each. Square is 360 divided by 4, you get 90 each. Okay, so a five-sided figure, you take 540 divided by 5, and you get 108 each. And as you go up higher and higher, let's say you had that 20-sided figure. Remember that 20-sided figure where we had 3,240? So let's say we had that 20-sided figure, 3,240. If we divide that by 20, it tells us how much each angle would be in order to have a perfect, or not perfect, but regular triangle. So if we take that, divided by 20, the number of sides, tells us that each angle should be 162 degrees. Now the reason why I'm telling you this is to figure out what the exterior angles are. Okay? The exterior angles, as I said earlier, all add up to 360 degrees. This trick only works if we have regular polygons. Okay? So to figure out, there's a little trick, just like we had a little trick right here, with figuring out the exterior angles. If it's a regular polygon, like this, let's say equilateral triangle is a regular polygon, you always do this. You take 360 and you divide by the number of sides. So for this one, you have 60 interior. So you have three sides, so you take 360 divided by 3, and that means that each exterior angle on a regular triangle, or regular polygon, meaning an equilateral triangle, should be 120. On a four-sided figure, the numbers don't change to 360, but you divide by 4 this time. It would be 90 degrees each. Five-sided figure, same idea, except for we're taking 360 divided by 5, and we should get 72. And when it gets to something like as high as a 20-sided figure, you still take 360 divided by 20, and you get 18. That means that every exterior angle on a 20-sided regular polygon should be 18 degrees. So the reason why I tell you all of this is this. You're going to get a worksheet here in a sec. It's going to tell you a couple different things. So, this is going to base off of what a regular polygon is. Okay, so this worksheet is going to be based off a regular polygon for a part of it. The other parts will just be polygons in general. So, it's going to tell you three things. It's going to tell you either the number of sides, it's It's going to tell you the interior angle sum. It's going to tell you the measure of one interior angle. It's going to tell you exterior angle. And it's going to say the measure of one interior or exterior angle. So I'm going to make this quick so that you guys can get started. So the number of sides. Okay, so it's going to ask you, it's going to tell you one of these 5 things. Let me get this in a better position. It's going to tell you one of these 5 things, and you're going to have to find the rest. So if it gives you the number of sides, it's pretty easy to figure out the rest. So the number of sides, let's say we have 6 sides. Okay, so an interior angle sum, well, we're going to take how much, we're trying to figure out how much the total amount of interior angles are. So you're going to take, this is where you use the n minus 2 formula times 180. Okay, so n minus 2, so we're going to take 6 minus 2 times 180, which will mean that's going to be 4 times 180, which will be 720. Okay, so that's the interior angle sum. The measure of one interior angle, well, we just figured out the interior angle sum, so we take 720, divide by number of sides, which is 6. So this should be 120 degrees. This next part should say exterior angle sum. You should always put 360 for this answer. Why? Because remember, exterior angle sum is always 360 degrees. Doesn't matter how big the thing is, it's always 360 degrees. The measure of one exterior angle, however, is a little bit different. Just like what we did up there, you take 360, divide by the number of sides, and you would get that. Okay, so that's how you find each side. Remember, this is 360 divided by n. This is always 360, and this is always n minus 2 over 180 divided by n. So this is different formulas to figure out each thing. So, well, let's say they gave you the interior angle sum. Let's say they gave you, I don't know, 900. The interior angle sum is 900. Well, this is what you got to think about. Okay, so we need to find the number of sides. How do you figure out the number of sides? Well, we know that we need to first, we have n minus, so we know that this 900 was figured out by taking n minus 2 and multiplying it by 180. Okay? So this is just simple algebra from here. So you can do one of 2 things. You can distribute, we'll just actually do what we did in algebra. That way we can figure this out. So first, you have this little formula right here. So we're going to distribute this 180 to each thing. So you're going to get 180 n minus 360 equals 900. We would add 360 to both sides. You get 180n equals 1260. Divide by 180. Divide by 180. You should get n equals 7. Okay, so that's how many sides we have. So once you've figured out how many sides you have, you'd start going through this process again. Um, from there, um, that's from there. You're just going to figure out everything else. I will help you guys out when you need it. Just let me know. Thanks. Bye.